looking at the end, getting to making production quality graphics and charts using R. Today our focus is going to be making sure folks have been able to get the software installed and doing some introductory work on learning how R actually works. So our presenter this year is Dr. Chris Chizinski from the University of Nebraska-Lincoln, and I'm going to turn things over to him now. If you have questions during the session, please chat those to me. I'm sitting right next to Chris, and I'll pass those along, and we'll address those as we are able to. So with that, thank you, Chris, for being here today, and the show's yours.
Thanks. Can everyone hear me? Yeah? Okay. Well, thanks, Keith. I'm glad to be here. I've been an R enthusiast for quite a little while, which I'll go into. Really enjoy getting to show all aspects of R, especially just some of the basics. I have a presentation that I'm going to kind of go through today, just going over some of the very basics on how to install R and RStudio, which are the two big components to doing any sort of analysis in R. I plan on talking basically about that and some just background into R, what R is, why R is good, why it's bad. And then next time I plan to talk to you guys about just some basic data structures and some data manipulation. So at any time, if you have any questions, like Keith said, please pass the questions on to him, or after this, I'll give you my email, and anyone who has any problems can email me anytime. So once again, thanks for coming and listening to me. How do I share my?
Share me at the top. It's going to be hiding where between you.
Go up to the controls. There should be a share menu at the top, and that should be able to share your screen through that.
It used to say share stuff. Oh, here we go. I got it. Sorry about that. See it? Okay.
There it is. Good.
Okay. So this is a presentation that I put together that I've gone over, and I've taught this a couple times so far about some just basic introductions. This will be available to anyone who wants the presentation. I'm happy to share it. A little bit of my background. I am a Assistant Professor of Human Dimensions, Wildlife and Management at the School of Natural Resources at University of Nebraska-Lincoln. I just started here last year at this position. Before that, I managed the state's Angler Survey program, and as part of that, I work with Keith closely about revamping the analysis and approach that we've taken to doing Angler surveys. And as part of that was rewriting all of the creel analysis in R. We've done some pretty cool things where we have the analysis, we have production of publications or documents and reports all done through R. So it's been pretty exciting, and I have been trying to push and try some of this in my new role too. I've been an R enthusiast since about 2007. I was before that trained in MATLAB and SAS and SigmaPlot, and then after I graduated my PhD, moved to University of Minnesota in St. Paul, and didn't have all of those tools, didn't have all the money to buy all those things, and so I was kind of forced to learn R and really embraced it. It took a long time, a lot of beating my head against the wall, but I've really become a big proponent of R, and now that I've been here at University of Nebraska, pushing a lot of the graduate students to learn R, pushing the Nebraska Game and Parks folks to take up and learn R. I've been leading an R group here at the university since about 2011 or 2012. We meet every semester. It's ranged everywhere from 5 graduate students to we're close to 20 people now. That includes faculty, grad students, personnel from Game and Parks. So it's become a big group here. It's exciting. Keeps me on my toes. Some contact information here. If you, like I said, if you want to get a hold of me at any time, feel free to email me. I check it frequently, and I've gotten pretty good at trying to understand conflicts and issues on R over email. Also, you're welcome to go to my lab website on here. I've got some R notes, so I've been doing some different things with R, creating web pages and some walkthroughs here that show you how to do some data analysis. This is another source for you to learn different aspects of R. I also have a GitHub page, and I'll talk a little bit about this too. But you can see that I've got several repositories, my blog, the S&R group here, which is our R group that I mentioned before, and I have a repository for this workshop. So all information, this presentation, everything will be housed in this repository. You are welcome to go in and download, copy things from there. So a little bit about this course. The purpose of this series is to provide a basic introduction to R, how to import and export data into R. Once you get that data into R, what do you do with it? How do you manipulate the data, change things around? And then finally, to take that data and to create presentation of application quality graphics in R. And I think that's one of the big strong suits that we have with R, is that we can do the analysis, we can do the programming all in one environment, and then also output that in the same environment. Really adds to reproducible research. You don't have to copy and paste into Excel or any of those kind of things. So a lot of the stuff we'll kind of go into next time about what packages are, but this course will pull strongly from what's called the Hadleyverse. Hadley Wickham is a chief scientist at RStudio, and he has been really instrumental in changing R and creating packages that have made a lot of data use and data analysis a lot easier. And so his collection of, I don't remember how many packages they are, but there are lots and lots of packages authored by him are called the Hadleyverse. And I've provided a link here. It's called, it opens up here, The Hitchhiker's Guide. The Hitchhiker's Guide to the Hadleyverse. So kind of just a little run through of all the packages that he's done. So this is a light reading. It's pretty cool. So repositories, I mentioned before, I provided some repositories of the R code, any of the presentations, and potentially, if I can get the links, the recorded webinars through the GitHub page. So I will have that up there. You can look at here the repositories, what it looks like. I don't have an R folder on here now, but you can come here and you will have access to the folders. Right now, this is set up for the web page, so you can see all the CSS and files and stuff like that. But I will have a folder for R script, the markdown pages, and any folders. And then you can click or download. For those that know how to use Git, you can just download, as it will zip it up into a file, and you can download it onto your computer, and you have access to it all. Kind of tied through that, there's also a GitHub page that's more of a web page focused thing. Well, I can have some links and stuff like on here, and then you can download the material. So everything that we do over the next couple webinars and into the actual on-site seminar, I'll house in here. And like I said, as we go through this, any questions, just hurl them Keith's way, and he can pass them over the desk to me. So let's get started going into a little bit about R. So what is R? R is an open sourced object-oriented computer language. It's really good for data analysis. You can do pretty much everything that you can imagine to data in R. It also has a programming environment, so you can create simulations, you can write your own functions. It is an object-oriented computer language. Just basically what an object-oriented computer language is that there are classes and methods. So an object has a class, that sets and defines the methods for that. There are, I won't go into too many of the details. You don't really need to know that necessarily to work within R, but if you are interested here, there's 3 or 4 different systems on how the object orientation works in R, and provided a reference to one of the advanced R books. So it's extremely versatile. When I looked last week, the central repository of our packages, one of the main central repositories, had over 9,000 packages. So it includes everything from multivariate statistics to data, graphics to video analysis. It's just very, very versatile. And part of that versatility has led it to become the 5th place in the IEE language rankings. So we look here, this just came out a few weeks ago, about a month and a half ago. And you can see that R has moved up to 5th place, right below C++, or right below C++, Python, Java, and C. So you can see that it's really being embraced by the research communities, data scientists, all of those kind of things. So in tying into that with the versatility, like I mentioned before with our Creel stuff, that you can write documents. So you can write Word documents, PDFs, HTML, all through R and RStudio. In fact, this presentation that I have here was all done in RStudio and R using the Slidify package, which creates HTML5 presentation documents that are all encoded, the CSS, all of those kind of things. It's a very, very nice system. So why do we want R? There's several reasons why R is beneficial. One, R runs on Windows, Mac, OS, and Unix operating systems, so is available to a wide variety of users. You're not limited to just PCs. Tied to that, it is open sourced. So with that, it is free, which is always a huge thing when you compare that to SAS, which is well over $1,000, I think, for a license. As I mentioned, with all of the packages available, so that central repository had 9,000 libraries. There's a lot of libraries available through GitHub, a couple other RForge, other repositories. So there are just numerous numbers of statistical tools, and you can write your own. So if there is something out there that you do not like or that is not available yet, you have the ability to write your own functions. So I hinted on this earlier, mentioned this earlier, that R produces publication quality graphics in a variety of formats. You can have interactive graphics, you can have, you can output it in almost any different format that you want. You have a lot of flexibility in how you produce these. There are several different packages that you can use to produce those graphics. One is just within the base R itself. There's the Lattice package, and then there's the ggplot, which is the package we will be using in our seminar. I mentioned this already too, that R allows you to generate documents in Word, PDF, HTML. There's a lot of options for you here to create documents to maintain reproducible research. R can be integrated with many other programming languages, so Java, Python, C++, all can be readily integrated into R. R actually really well integrates with C++, which has many good benefits for working in R, like speeding up the process times, all of those kind of things. And not only can R be integrated with other programming languages, there's also the ability to integrate it with other packages or other software. So as an example, there's a new package that just came out called QGIS, where you can integrate directly into Quantum or QGIS and do your spatial analytics that way. You can integrate it into MARC, so MARC recapture studies. you can tie right in. AD Model Builder. There's lots of ways to integrate into other software's packages. R scales. You can use it for just small, simple statistics to much larger statistics. For a while, R was limited on how much data that it could hold into memory. It was kind of based on how much RAM you had on your computer. But there's been some advances on making that better, including with Microsoft embracing R, and now has added a huge big data component so that you are not limited to necessarily to just how much memory or how much memory you have. So there's a huge user base. So given that it's increased in popularity, moved up those IEE rankings, there's lots of blogs, lots of answers on the web, and you're guaranteed to have lots of questions as you do this and learn R. The other cool thing about this huge user base and that it's open source, if there is, you can contact the people that wrote the packages. So as an example, I was working on some multivariate statistics way back a few years ago, and I was trying to get some data output from this analysis, and I contacted the guy directly. He went in and changed the function so that I could output that data, and it took just a couple days to have that whole process done. So usually it's a very good user base, really friendly for the most part. Lots of ways to get answers to the questions and help you on your way to learning R. So the other nice thing is that R steers clear of point-and-click analysis. So you do have to kind of understand what is going on in your statistics. It isn't necessarily that you can just click and have an ANOVA run for you. You do need to understand what is going into there. That helps you better understand the output that you get back. You don't necessarily just get default responses on things. That is a huge benefit, I think, for R and for statistical analysis. So there's lots of benefits of having R. There's also some things that R is not great at. And this pains me to say it, but R can do a lot of things, but it cannot do everything. As much as I like to push and say that it can do almost everything, there are some things that it cannot. There's a decent learning curve, and I think this is one thing that keeps a lot of people away from coming and embracing R. You really have to spend the time to learn how to do it. We'll go into a couple things that I think are some hurdles that people have as they try to learn R and get into it, but you do have to put your time in. There's been many improvements over the years, but some of the documentation can be pretty opaque. You think about all those thousands and thousands of packages out there. Some people are better or not at documenting what they're doing and why it's being done. There are still some packages and stuff out there that you just don't know exactly what is going on in here. And then because it's open source, there can be really innovative stuff that are just developed, and then the packaging still hasn't been done yet. So that's another area. Kind of tying into all of these things up above, working in R, it's guaranteed you're going to want to just scream and yell and throw your computer through the wall at some point. It probably happens to me at least on a weekly basis. There's just some hiccups in everything that goes through, whether it's understanding error codes, trying to get it to do something that it can't do, or trying to understand documentation, but you will get frustrated at R. So contributed packages go through lots of testings for any of those central repositories, but some are better and more reliable than others. There are some that just for some reason you can't get running on a Mac or Linux. They're only PC-based. There are frustrations there that come with this. So why not R? So also it is a benefit, but it also can be a problem. That R steers clear of point-and-click analysis, so you do need to understand the statistics behind what you're doing in a lot of cases. Some users may just not want to deal with that kind of stuff, and that may be a roadblock enough on there. But I think that the benefits generally do outweigh a lot of the problems with R or some of the negative aspects of R. So where can we get R? We'll start talking about installing R. So you can download R from CRAN. This is that comprehensive R archive network that I mentioned. This is where all the packages are housed. There is a pretty defined pathway that packages have to go through here. They go through a lot of testing, but this is also what houses base R. And you go to here, and you can see, go to downloads here. You go to base R, yeah, this is the base CRAN page, and you can go download and install R. And you can see that you have many different options here. For Linux, you can choose which version of Linux you have, but there's some different pathways to install from these. A lot of these different installations have different mirrors, so you have to go through the mirrors and find out which one is either the closest. There's some cloud ones. There's a lot of different options. We'll show you them in a second, but you have to replace this right here with your favorite CRAN mirror. Generally, I choose the CRAN location that's closest to Lincoln, but it doesn't really matter. I haven't done Linux installations in a long time. So, Mac's a little simpler. You click on the Mac one. The first one that shows up is the top most recent stable version. This one right here is R331, Bug in Your Hair. It was released mid-June. And so you can just click this, download the package. Once it's done, you double click on it, install it into your computer. It's really, really simple. So PC is a little bit different pathway here. So here you have several different subdirectories you can go to. You can choose base, the contributed, the old contributed, or R tools. To install R here, you want to use base. So you click on here, and you're brought to this window here. And you want to download the top option there will be the most recent stable version for Windows. I'm going to tell you the size. You can have 32 or 64-bit. You can click on that, and it will download the exe file. Double-click on it. I tend to follow the standard options for installing it, standard locations, all of those kind of things. It helps later on when you're trying to set pathways and that. But if you just keep it standard for your operating system, it's easier to point things in the right direction when you're trying to integrate across packages or different software. I also would strongly encourage people that are trying to have PCs or R to also install R tools. So R tools has the option, or gives you the ability to install or build from source a lot of packages. You want to make sure that you choose the version that is closest to you. So if you just downloaded R331, you would also want to download R tools 33.exe. Like I said, this will allow you to give you a couple other tools if you need to build packages or any of those kind of things in R, which some packages do require. So it's nice to have this ability. And this, I usually just install just right into the default C spot too. As I mentioned, it can be installed on Linux, Windows, or Mac operating systems. I always go and choose the most current stable version. You can do the first one, but there are some things that they're working through bugs that can cause problems. So it's good to keep the most current stable version. And as I mentioned, if you're downloading for PC, I would also download the R tools. You do not need R tools for Mac or Linux. The other thing that as I've worked with people on R a lot of times is that they'll download it one time and just let it sit for a long time, and they'll be working with an old version. They do, every few months, they come out with a slightly improved version, bug fixes, all of those kind of things. But you want to make sure that you're updating it frequently. You don't have to do it every 3 months or anything like that, but I would try to do it at least every 6 months to make sure that you get the most current version. And because the functionality of the packages that you want to work with depend on the version of R. So update frequently if you're going to use R. Is there any questions on installing R or anything like that? It's fairly straightforward going to that site. Do you have any? Pass them on to Keith. So how do you run R? There's 2 options. So once you install R, you can run it from base R. Find it here. So this is what base R looks like. This screen right here is the console. So this is where all the analysis and results are displayed. As an example, 2 plus 2, hit enter, outputs the 4. So you can do all your work in the console, or you can work from scripts. File, document. Oops. So this is a script. You can also do your 2 plus 2 here, and then send that to the, oh, that's the wrong one. You can tell I don't use the console very often, or base R very often. Go back to here. Find it. Did I not save it?
Yes.
Well, I'll show you again here with scripts in RStudio, but you have the same option in base R. There are some differences. You can see from here that it's very basic. You get black for just basic text. Any sort of errors are in red. Your numbers are in blue, output are black. It's kind of just very basic, not a lot of bells and whistles here. There's a better option here, and I highly encourage that if you are going to work in R, that you use RStudio. And RStudio is an IDE that runs R. You do need to have both of them installed. So you can do everything in R, but RStudio just makes it a much more pleasant experience, and I'll kind of show you some of that stuff here. To download RStudio, go to rstudio.com. They have a couple different products here, but right off here at the top is RStudio, and you can just click here. And there's several different types here. There's commercial licenses, there's RStudio servers, Server Pros, but what you want here is this RStudio Desktop, the free license. It's integrated development environment for R. So you do need to have R installed, the base R that I mentioned, and then RStudio to run R. And you can just click download, and you'll come up with the different platforms. There are several different supported platforms, PC, Mac, and several different Linux versions. So once you get that installed, then you can open up RStudio. Open this up here. So the way that it's set up, you can change this around a bunch, but here is the script window. Here is the console that we had before in base R. Clear this off. So same thing that we did before, 2 plus 2. We get our 4s, but up here we can also do 2 plus 2, and then run this which outputs it down into the console. And so there's many, many benefits to doing it in this way. The other nice thing is that RStudio has shows you the environment, stuff that's saved into the memory. You can view your code history, any files that you have associated here, packages that you have installed. You can click and install or update any of the different packages. The other nice thing is that it has a viewer, so you can look at HTML, you can look at presentations. There's a lot of different options. The other nice thing about RStudio is that if you go to Tools and Global Options, you can change a lot of the ways that the code is handled. So code, you can have them automatically auto-indent. You can soft wrap the code so as you write it, it spills over to the next page. You can have it automatically close parentheses and quotes. The appearance of what your editor looks like. If you're looking at R all day long, as I do, it can really bug out your eyes if you don't have the color set correctly, which is not something you can do in base R. You can change the way that the panels are laid out, so you can have your source over here, you can have your console on this side, and then where you have plots and stuff show up. So it's really, really flexible. It does syntax highlighting for R, auto-completion. Yep. So you can start writing functions here. Start writing ANOVA. So as an example, if you wanted to do ANOVA, it tells you what the function is, here's the name of the function. Here is the package that it's in. It's in the stats package. And then kind of gives you just in a brief window of what maybe needs to go in there. So it does a lot of cool things. It gives you the ability to do different files. So R script is what we basically work on for analysis. R Markdown is based on the Markdown language. It allows you to directly embed R into Markdown language, and it will automatically convert it all for you. There's the Shiny web app, so there is a series of packages that you can develop HTML web applications from R, and that's all done through RStudio. And just basic text files, C++ files. If you want to generate latex documents, you can do that all through here. And as I mentioned HTML earlier, there's encoded presentation modes. This isn't the one that I'm using for this talk here, but there is RStudio has its own presentations. And then also to help with documentation on new packages that you create, there is R documentation. So it's a really, really flexible system. It gives you lots and lots of things to work on. And in a nice environment. And I've seen that there is similar pushes for people that work on Python for a similar type of environment here. So lots of cool stuff here. So like R, I also would encourage you to, on a semi-regular basis, to go in and update your RStudio. So if you go to Help, you can go for Check for Updates here. That will go through and check and see if you have the most current version of RStudio. And having both R and RStudio on equal footing is really good. The other cool thing here is that RStudio really has pushed for some of these cheat sheets. So you can go in, there is an RStudio cheat sheet. You click on here, and it will actually bring you up to the cheat sheet on how to use RStudio and how it's broken down, some of the different stuff that you can do with RStudio. So as you can see, there is quite a bit. There is a debug mode that you can have. You can work with version control on GitHub or SVN. And then the next page here has all the shortcuts. So you can see there's a lot of shortcuts that kind of improve and speed up your R using experience. couple other ones. Cheat sheets. So there's data manipulation. These are the two that we are going to be going over with in our seminar. There's markdown cheat sheets, reference guides, how to do Shiny web apps, and then package development. So a lot of help embedded in here too, which is very, very nice. So yeah, as I mentioned, it includes a code editor with syntax highlighting, debugging, and visualization tools. And there's this cheat sheet link here is to the RStudio cheat sheet link. There are some really, really cool things that you can do with RStudio with those cheats that really improve the design. So running R, I mentioned that there's the console and there's the script. I tend to use the console only for one-off things like installing packages, that sort of thing, where you only need to run it once. It is good practice to use the script editor more often. This keeps all your code in scripts, so you can save the script file and then load it back up again. If you're doing any sort of analysis, you're going to reuse code over and over again. It's nice to not have to keep redoing it over and over again. The other nice thing is that it really allows for reproducible research. So you can give someone else your file and all the data, and they can go through and get the same exact results that you have. There isn't things like taking the data out, putting it into Excel, putting it into another graphics program or into another program. You can keep it all in-house. It's completely reproducible that you give to somebody else. The other nice thing about scripts that I meant to show in RStudio is that if you keep a common data structure or data directory, I use Data Depot. See that? Go to my documents. Data Depot here is where I keep a lot of my R analysis here. I keep all my code in one location that really helps when you need to come find it later on. And RStudio has a nice thing that you can go to File, it's Edit, you can find in Files. So if you have a whole bunch of R script and you don't remember which file it was in necessarily, you can point it to the directory and put a keyword in there, and it will search through all those R scripts and pop up on your RStudio which files contain those things. So having a centralized directory is important. I also tried to make sure that you do good housekeeping on your script files, so to make sure you label them. I usually try to provide some sort of description of what I was doing and then the most recent date that I was working it on. So if I'm working on some script over many, many different days, I will have several different versions of bird analysis, 8.17, 8.18, 8.19, and so on. That way, if I need to go back, something got messed up, I can go back and not worry about it. And all R script files have this just .r file type. So how do you learn R? As I mentioned earlier, R is not easy. It takes time to kind of understand some of the nuances and things like that. The best strategy, I believe, is immersion, 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 to just really dive in with both feet and force yourself to learn R. It's in many ways just like a foreign language. If you give yourself an out and not really push yourself to understand the language, then you're not going to get it. So it does take some time. That's part of the learning curve, but you just need to keep pushing at it. And by really pushing at it, you start recognizing the nuances of the language. Understanding what errors mean is a big thing, and this will allow you to use it to its fullest ability, even providing you the ability that if you need to hack something or a workaround, you'll be able to do that. And I think that once you do this, put the time into it, the payoff is huge because it opens up a huge world to you for all sorts of opportunities. Some hiccups in R, so newbies to R, including myself, still tend to get hung up on 3 primary areas when learning R, I think. One is getting data into R, and we'll talk about this in the next webinar. There's many different ways to do it. Some of them are very confusing and don't make sense, but there are a few packages that I think are the way to go to getting data into R. Understanding the structure of your data, so once you get the data into R, what does it look like? How do I look at certain rows, columns? How do I work with the data that I have? And then the last one I know everyone has problems with is understanding the error messages. They are very cryptic in a lot of cases, but once you start to, like I said, learn the language, you can understand what those error messages are saying. So how do you get help in R? As I mentioned, there's a large and diverse user base, so there's a lot of help out there. There's many sources from mailing lists to Google groups. I think that there tends to be, there's a continuum of frequentness across those. So our mailing lists, you tend to get the more grouchy folks. If you don't ask the question the right way, they will let you know. But there are several of them available. So there's R announce, there's R help, there's package development, there's development R packages, and then there's several special interest groups here, as you can see, from teaching all the way up to just Mac focused. There's an ecology one. There's the geo one. So there's a lot of different options. You can join these mailing lists, get them in as digests. You can participate in them. The one that I like and go to probably the most often is Stack Overflow. This is nice because people can produce or can ask the question. You can provide an example here so you can understand how it relates to your data. And this one doesn't have it yet, but people can provide answers to that, and then people can vote on how appropriate that was. Let me see if I can find one here. This row's the list. So you provide the data, kind of a description of your problem, and then some questions. People may provide some immediate comments here. But then here's the answer. So here, 4 people voted this one to be the top answer. It gets the check plus, and it kind of shows you right there. It's a really good way to see the really good format to get some answers there. And Google Groups. And Google Groups is a little more specific. This is for the unmarked package. This is for calculating population abundances or occupancy of unmarked populations. It's set up very much the same way through Google Groups. This tends to be the friendliest of the continuum, these side of things. You can see that there are several different Google Groups here: unmarked, ADM model builders, Google visualization, ggplot. There are several of them out there that you can get some really good answers and really quick. To the Stack Overflow and the Google Groups, I think you get really quick answers there. So kind of like that there are 3 areas that I think people struggle with. I think there are 3 areas that new users to R get tripped up on when they're trying to find help. So first, how do I do so-and-so in R? My suggestion on that is just to do a Google search for it. So if you wanted to learn how to do a Google search or to know how to do linear regression in R, I would just do linear regression in R. And right there, it pops up. You see that there are several different help sites on there, tutorials. There are some PDFs. There are some videos. A lot of things will pop up. So if you just have a very basic question on how to get help or how to do something in R, I would just search the basic thing that you're trying to do, and then add and are. You will, a lot of times, get some pretty good results up there. So generally, these results will include tutorials, packages, and questions posted on online help sites. So the next part on there is how do I use this function? So you did the search already. You found out that you needed to do a certain function. There are two ways within R to get help. So we searched linear regression. I told you you used to use the function LM, which would be the function. So to find help in R, you just can do $LM and then run that, and it will bring up a help page for you within RStudio. So in here, it tells you this is the function name. These are the materials or the parameters that need to be in the function. If it has an equals here, that means that is the default. So you have different options here. And then within the next section down are the arguments describing what each of these parameters are in here. It will also provide some details about it, how it's doing the analysis, those things. And then the value is what it outputs from your function. So the help here provides a lot of data or a lot of information. And I think a lot of times people will skip over this thing and not understand that they can find exactly what they're looking for here. The other nice thing is that it provides reproducible data and ways to go. So this is all just something you can just copy, paste here, run this, and you can get the results. So if you're doing that, this sometimes, and you're getting areas you don't understand, this is a good way to start using some of this data to figure out maybe what's going on with what you're doing. The other thing you can do here is, so if you don't know exactly a specific function, you can also do a general search. Oh, I guess one other quick thing before I do that. You can also do it, instead of just question mark the function, you can get the same thing by doing help, parentheses, and then the function name inside. Oops, gotta get through the whole thing. So brings up the same thing there. You can also, if you have just a general idea and you wanted to search regression, you can do a double question mark. This means just a general search. And you can, oops, not right. So this will do a broad search across packages. Oh yeah, here we go. So provides, here's some vignettes from all different packages. These are the different packages. These are the functions there that within those packages that will do the analysis. And like, you can have a PDF, you can have the source, you can have the R code, all of those kind of things to go back and reproduce the stuff. So the double question mark is another helpful way to figure out some general process, like a Google search. This is almost always where I start when I have particular problems, because it will tell you what your input parameters are and your various options. And a lot of times you can figure out what's going on there, because usually it's because you're doing something wrong. You're putting the data in wrong. You're calling something incorrectly. And then the last one, as I mentioned, is understanding error messages. Part of this will come in with time as you invest effort into understanding how R is. But sometimes you're just going to get an error message that you have no idea what it means. And what I will do often is just take that error message right off the console, paste it into Google and do a search. And pretty much 9 out of 10 times, somebody will have posted on Stack Overflow or somewhere describing that error and how to get around it. A lot of times it's you forgot a comma somewhere, or you are trying the wrong kind of data, those kind of things. but it'll pasting and Google searching the error message helps you 9 out of 10 times. So finally, asking for help. This is Hadley Wickham, which I mentioned. He's an active Twitterer. Our community, whenever you're asking for help, they want reproducible examples. So was specifically venting here about in bug reports, but anytime in Stack Overflow or on the mailing list especially, they want to have reproducible data. And it can be difficult on how to figure out some of that reproducible example. But the key to getting good feedback, no matter what it is, whether it's the guy down the hall or a mailing list, is to do your homework first. The first should always be Google search the issue. If you are going to post it, don't make it seem like you're asking a question about a homework assignment. There's been many times that I've been yelled at because I made the question sound too much like a homework assignment, and they will just actually remove it right from Stack Overflow. So it's kind of a pain. But the other is to provide a reproducible example, as I mentioned. And Stack Overflow actually has a really good page here on how to make a great reproducible example. One, it defines on what it is, but some of the different stuff. So producing a minimal data set, even if it's just simulated data. You can copy some of your data if you're not actually worried about someone stealing your data. You can just copy parts of it. You don't have to give the whole thing. You can just do a small segment. Producing the code that you did to analyze it. And then any extra information. This could be like including your operating system, the versions of R you're using, all of those kind of things. Generally, if you do those things, you will get good results from people, and they'll be willing to help you. It is a good community out there that's willing to help. So that's all I had for today, kind of just giving you a basic overview of our studio, and some of the trials and tribulations that go on with learning R. Next time, I would like to get into some of the data, so getting your data into R and some basic data structures and how to work within R. And with that, if there are any other questions, I'd be happy to answer them. Like I said, you can also email me. I will put this up online. If you have any questions on trying to install our studio, I am more than happy to help. Thanks.
We'll make sure we get the links to Chris's pages up on the OFWIM site as well, so if you want to be able to grab some of that information. Next time we'll get a date out probably in the next 2 to 3 weeks here for the next webinar that we're going to follow up on. So come with R installed, and we're going to be working with some numbers at that point. Is there any questions anybody has before we sign off for the day? All right, thank you for coming, and we'll let you know when the next session will start up. If you haven't had a chance yet to register for the conference or to submit your abstracts, this is the final day for early registration, but we are still accepting abstracts and registrations for Ponca. Please go ahead and work on those if you can so we can start finalizing our planning for October, and we look forward to seeing you soon. Thank you, everybody.